What we are going to do is we are going to solve a system of linear inequalities. We're going to use a graphing method because that's the only real method that will show all of the solutions that we could possibly have. Because for a system of linear inequalities, there's always an infinite set of solutions if there's a solution. So what we're going to do is graph each one of these lines one at a time. You'll notice that I have my first line labeled as number 1 and my second line labeled as number 2, and I'm going to do these in 2 different colors so you guys can keep track of what's going on here. I am going to solve and shade each one of these one at a time. The first line that I'm given here is in standard form. What I'm going to do is I'm going to rearrange this into slope-intercept form because it makes it a little easier for me to graph, and then I also don't have to worry about any decimals if I try to put it in standard form, or try to graph it in standard form using my zero table or getting my x and y intercepts. So on my first line, I'm going to start off with my first thing here. 3x plus y is less than or equal to 1. And I'm going to subtract 3x from both sides to get y by itself on one side of the inequality. So this equation, my first equation 1, is going to start off as 3x plus y is less than or equal to 1. I'm going to minus the 3x from both sides. And when I do that, I'm going to end up with y is less than or equal to a minus 3x plus 1. And now I've got that in slope-intercept form. Makes it a little bit easier for me to graph. I can see I have a y-intercept at 1. So I'm going to go up 1 unit on my graph. And then from there, I'm going to go down 3 over 1. Because if I make this a rise and a run, it's down 3 over 1. So down 1, 2, 3 over 1 unit. And then I'm looking at this thing and I can see that there's a line underneath my inequality here. So that means that the line that I'm going to use as my boundary, or the line that I'm going to graph, is going to be a solid line. So this one's going to be a solid line in red. I'm just going to sketch that in. And then I need to do some shading as well. So I'm going to use this this equation that I have here, inequality, and I'm going to choose a test point, and I'm going to evaluate that test point to see which side of my line I need to shade for this. I'm going to use 0, 0 if I can, because it's the easiest one to evaluate. In this case, I can because my actual line doesn't pass through 0, 0. Remember, I just need to use a point that's not on my line when I'm choosing a test point. So I'm going to put a 0 in for my y and a 0 in for my x, and I'm going to evaluate this down. Now when I do this, the 0 on the left side stays a 0, negative 3 times 0 becomes 0, and then on that right side, 0 plus 1 is going to be 1. So when I evaluate this whole thing down, it's going to end up being 0 is less than or equal to 1. That's true. 0 is less than 1. So what I am going to do then is I am going to shade towards my test point. So I'm going to shade all of the stuff on this side of my red line. Now I'm going to go back and I'm going to do my second line. I'm going to go through and do this one, and this one's nice and easy. My second line, when I'm looking at this one, I'm going to do this one in blue. It is x minus y is less than or equal to 3. And this one is really easy to use a zero table. If I choose a zero table for my x and my y, and I find my x and y intercepts, when I plug a 0 in for x, I have minus y is equal to 3. And that's just going to mean that if I have a minus y equal to 3, that's a minus 1y, right? So a minus 1y is equal to 3. And I would divide both sides by the negative 1 to get y by itself, and that would be that this is going to be a minus 3 here. If I put a 0 in for my y, that means that that's going to cancel out, and I'll have just x is less than or equal to 3. So I just have a 3 there, so I have both of my points that I need in order to graph this. My first point happens at 0 over 3 down, so I'm going to be at 1, 2, 3 down right here. And then the second point is going to be at 3 over and 0 up, so 1, 2, 3 over and 0 up. And again, because this inequality is or equal to, it's going to be a solid line, so I'm just going to sketch that one in real quick. And then once again, because I need to do some shading here, I'm going to choose a test point. I can still use 0, 0 here because my blue line doesn't pass through 0, 0, so I'm going to plug that in and see if I'm going to shade towards my test point or if I'm going to shade away from my test point. When I put a 0, minus 0 in for my x and y, and it's less than or equal to 3, well, 0 minus 0 is 0. That is less than or equal to 3. It's definitely less than 3. So 0, 0 is a true test point, which means that I'm going to shade towards my test point because it gave me a true expression. So in this case, I'm going to shade this way. And again, just so you guys know, the area that got shaded 2 times is going to be the area that is my entire solution set. It's going to be this whole mess right in here. This is the area that got shaded by both the blue and the red, and that's it.